Hello, in this video we'll be talking about the fifth and sixth properties of water. So let's not waste any of your time. Let's get right to it. Now, in the fifth property of water, what we're going to be looking at is the fact that because water is a polar bond created by the fact that the oxygen atom is pulling those electrons slightly closer than the hydrogen atoms away from it. It creates that positive and negative end, which we discussed about already in an earlier video. And when it does that, it makes polar molecules, which insinuates there are also non-polar molecules. And you're familiar with this. It's the idea of oil and water not mixing. Water would be a polar molecule. Oil would be a non-polar molecule. And therefore they won't mix. If they could mix, as I've talked about in my classroom for a long time, that would make the diet industry obsolete. Because if polar molecules, water, and non-polar molecules could interact and be dissolved, well, fat is a non-polar molecule. So to lose weight, essentially, drink a bunch of water, it dissolves the fat, boom. How great would that be? But as we know, and certainly I do, that is not the case. When it comes to the fifth property of water and how water organizes non-polar molecules. And we say the word organize, we're talking about affecting its location, affecting its availability, and affecting its overall shape. We know if we take a glass of water and we pour some oil into it, it doesn't just spread out like it would like to. Water kind of pushes it on the side and gives it a general overall shape. When we talk about this property, the two words that we want to make sure that we're familiar with, hydrophilic, hydrophobic. These two words you hear a lot about in chapter 3. It's in chapter 5, plasma membrane. It's the idea of water loving, hydrophilic, water fearing, hydrophobic. Water doesn't actually fear or like nonpolar molecules, or I should say nonpolar molecules don't actually fear or like water. What it means is that will it associate with it or not, and of course that means will it bond with it or not. If it's hydrophilic, it will bond with water. If it's hydrophobic, it will not bond with water. And of course it has all kinds of implications as we've discussed, and as we will discuss in the future in other videos. Okay, and this property of water, this is the sixth property of water, which is our favorite, mainly because it's the last property of water. But this property leads us into our next video when we talk about the pH scale. This particular property of water shows that water can be broken apart, and it breaks apart naturally. Okay, and when it does that, it generates other molecules. It generates an OH molecule, and that leaves the H also by its side. And when that separates, the oxygen removes the one hydrogen, or it still has it, I should say, and therefore you have a hydrogen without an electron. And if you're familiar with the periodic table, you know that hydrogen has a mass number of 1, which means it doesn't have any neutrons. It only has the one proton and the one electron, and when it loses that electron, now it just has the one proton, which makes it an extremely powerful element, and that's why it forms acids. A single hydrogen can form acidic material, which can be okay if it's a weak one, but it can be super strong, like a hydrochloric acid that can just simply eat through your skin, can be very dangerous. So when the water does separate, one part of it comes out as OH negative because it has that one additional electron, and that's what is a base. When we talk about acid and bases, a base is going to be the OH hydroxide. The hydrogen by itself, with only the proton, okay, that's what's going to be known or become an acid, okay, a hydrogen ion. And of course, as I mentioned, H pluses only have that proton, which generates a lot of power and potential. And our last slide here, it has a bunch, and this is the summary of all the things that we've talked about. If you've done a good job of taking your notes, you may not necessarily need this information, but just one last glance at it. It's the idea of water bonds to itself, generates surface tension, the hydrophilic, where it can alter other materials, capillary action, surface tension, the fact that water will, as a solid, will float in its own liquid. It has a high specific heat. In other words, it can absorb a lot of energy, which can modify environments. Heat of vaporization, which is our cooling. When we sweat, pulling that heat away from us. The idea of being a universal solvent. The idea of associating polar molecules, nonpolar molecules, ionic bonds as a solvent. The idea of bonding with materials that are similar, as in polar, hydrophilic stuff, hydrophobic. Excuse me. Those ideas, but all are super important properties of water. So that's our video for today. When we come together next time, we'll be talking the pH scale, which is our last video in our Structure of Atoms or our Chemical Foundations of Life, Chapter 2. So we'll see you then.